Well, good morning. Let's do the last piece we're going to do on GUI system software. And let's talk about integrated development environments. And it isn't going to be very long, and then we're going to move on to alternatives to things like the Finder or the Explorer, or in the land of Unix using the Nautilus Finder. But I think most of you that are using Linux are probably well aware that there is an alternative to it. We're going to take a little bit of a look at integrated development environments. I mean, that's the way that most of you were introduced to programming, and lots of you still write code that way. I use Visual Studio Core primarily for the debugger. So there are lots of different IDEs, like Eclipse for Java and PyCharm for Python. Hopefully you took the time to read the link that I have, which is kind of asking people not to teach this. I mean, there are lots of reasons why you, as an instructor in a computer science class, would want to start people out teaching it. Certainly, last semester I taught a 10-15 class here, and I had people learn how to not use IDEs. And I spent probably a quarter of my time during the whole entire semester working with people to figure out how to install stuff and how to edit stuff and how to work without them. Now, IDEs are phenomenal if what you happen to do is exactly what they're designed for. And virtually all the IDEs out there were designed specifically for the purpose of building desktop applications that interact with a GUI. Today, that's not even the most common case for building software. We're seeing in terms of the software market that there is a resurgence in the number of people using not C++, which was designed in the GUI era, or something like Java, but C, because most programs are ending up inside devices, information technology, IoT devices, not in desktop. And there's almost no activity in the land of building actual desktop applications. Those few desktop applications that are being built, like the Atom editor, are being built with web technologies with a local server on the same machine as the front end. That uses a system called Electron, and that's exactly what it is. You're actually running a copy of the browser on the same system that is kind of hidden, but it's built with HTML and cascading style sheets, and those are way, way faster to build things for the desktop than it is to actually build a desktop application. To give you some idea, I did an application with Electron to just show a series of slides. And the front end turned out to be about 160 lines of code, and the back end was about 100, and I did it in a few hours. Whereas if you went to build that same kind of an application, which I have actually done using the Windows framework for developing applications, you're looking at several thousand lines of code and easily a week or 2 weeks worth of development just to build a very simple image viewer. So it's a lot easier, a lot more straightforward. The testing model is easier with that. So I don't think you're going to see a lot of dedicated desktop applications. Now, the place where we've been seeing desktop applications, which is not quite a desktop, is things like iOS and Android. But today, most development for those is happening either through some sort of a web framework or a near web framework. Like Facebook has produced this system called React for the web, and they have another system called React Native, so you can reuse about 90-95% of your code between the two, and it's basically a web framework that runs on your mobile device for building applications. And lots of these things are built in that fashion. Certainly, if you're using Facebook and their modern version of their Facebook app on iOS and Android, it's built with React Native. So you didn't even know that, and it's being used that way. The IDEs, why do people teach them? Because you only have to install one thing, and you only have to get one thing working. You don't have to deal with, you've got an editor over here, and you've got another tool here, and you've got to get all these things to interact favorably together, and you've got to figure out how to install all of them. It's simpler for the students, but it also boxes you in. Now, the other thing that tends to box people in is things like the Finder or the Windows Explorer. You're used to just double-clicking on files and it does something. And under the covers, it's just opening a program and running it with this file with this default file extension. This is less useful in a lot of ways than alternatives, and we're going to dig into what the alternatives to this are. From a computing perspective, the double click is a single event, or the single click on things is an event that happens, and you go from an initial state to a new state with this program running. But it's not a program, and programs that are built on top of push-down acceptors are more useful than things that are just deterministic state automata. A good example of the limitations of this is, for decades, Microsoft has built a tool for building installers. And most people that developed software for Windows used their installer tool. The question is, what did Microsoft use? I mean, are they going to dog feed their own tool? And the answer is they used this thing called Wix for building installers. And Wix is not their tool. It's an open source framework for being able to build an installer, and it is all command line based. As in, you edit a program in Wix and it allows you to build the installer. And the reason why everybody at Microsoft was doing this is because their installations were too complicated for their own installer. So this ability to have a language where it is actually something you're sitting there in an interpreter running stuff gives you lots more capabilities. The other advantage is one of testability. If it's a language, then I can test it with things that allow me to repeat the test, to guarantee that my tests actually work in a repeatable fashion. It's very, very difficult to test things inside a GUI, because the only way to test things is to actually move the mouse around. And all you have to do to muck up this test is get the size of the window to be slightly different, and suddenly the mouse moves to a different location. It doesn't click on the same buttons. So getting repeatable tests is not trivial inside a GUI environment. Another thing that happens with GUIs is their real-time. If I come over here and I move my mouse, I actually expect when I move that mouse that it's going to happen when I do it. And when I click on something, I expect that it's actually going to switch to that screen basically in real time. It's not going to take time to switch between screens. So that as I'm working on these things, okay, I can get feedback as to what's really happening at that moment in time. And if you happen to be working on a remote system, or you have decided that the way that you're going to do development is, instead of using a computer that you're sitting at, you're going to do something like buy a large iPad and use a keyboard, and you're going to remotely log in to do all of your development over the network, which is actually becoming a common model of development. Or you're trying to do remote maintenance because you're at home and you have to log into your employer's network, or they run all of their stuff on something like Amazon Web Services, and the computers are physically located in Virginia and you're not. Or you're trying to do maintenance in someplace convenient like Tokyo because that's where your customers are and you're in Wyoming. Then this immediate feedback model doesn't work very well. The real-time model for moving the mouse is really horrible. So it's difficult to use any kind of a GUI tool in those circumstances. I mean, yeah, they exist, and I can remote log in to Macintoshes. I can do actually quite good remote login to Linux and Windows systems. The Windows remote access tools that bring up a desktop are actually very, very good. But they still have a dependence on you being able to move the mouse. And it's torturous to do that if it's not pretty much instantaneous. Another disadvantage of GUI systems is documentation. If I go out here and look at the documentation, okay, and I can do Q to exit out of this, but if I look at the documentation for a particular command, it is easy to understand what it is. If I look at the documentation for something that is GUI based, the only way that I get good documentation is if every time they click, they make a screen capture of what they're clicking on. Every time they change something on the user interface, they circle where they're typing into a field or what button they're clicking on. Otherwise, they give me a description, and I'm sitting there looking at the menu and going, okay, I've got to read this description of how they did something. Now I've got to look at the GUI, and I've got to figure out how the two relate. Where is this button that they're describing as the run button? Does it say run on it? Does it have a little airplane on it? Does it have a little switch that you're flicking somewhere on this? Did they move the button since the documentation was written? So the documentation is usually pretty horrible. And the last thing is just a question of, is it everywhere? And most computers don't have a GUI today. You have 3 billion iOS and Android devices, and 15 billion information of things devices, IoT devices that are running BusyBox. So most of them don't even have one. BusyBox is a command line. So there are lots of reasons to learn and use the command line. And it's been around for a long time. But the biggest reason is the one I'm going to talk about here.